Hello! Finally, this is the last chapter of this course. In chapter 12, we are going to study regression model, right? So, the regression is the ultimate goal of this course. So, the purpose of economic statistics is to equip you with the tools you are going to use in advanced economics courses. And then that is regression. Simply, what you are going to use is the regression, and to understand regression results, to interpret the results, you need to understand like p-value, confidence interval, and unbiasedness. All the things are needed to understand what you when you use the regression model. So that is how I designed economic statistics course. So we are here. Okay, now what is a regression? The regression is basically a prediction. It is to predict the value of one variable using other variables, right? So using other predictors, you would like to explain or predict, estimate another variable, okay? So in doing so, we need to use the estimation framework. Also, we are going to use hypothesis testing theory in doing the regression model, okay? Okay, let me start with a seemingly totally unrelated question. So, if you took intro micro or intermediate micro, you must have learned the marginal cost. That's the key term in profit maximization in microeconomics. So now we are going to assume that there is a firm, and the firm has a marginal cost of $2, say, and fixed cost of $10, right? So simply put it this way: when you open a restaurant, you need say $10, and then for each dish to make, you need $2 more, okay? And then in this case, given the marginal cost and fixed cost, what is wrong? A, when you produce 5 units, the total cost is $20. B, when you produce 1 more unit, the total cost increases by $2. C, when you produce 10 units, the average cost is $3. And if your budget is $40, then you can produce up to 15 units. What is wrong? So, it is warm-up question. You should be able to answer that. It is not that difficult. The answer is E. All the sentences are correct. So the first one, when you produce 5, then the marginal cost times 5 plus 20 is the total plus fixed cost is the total cost. That is 20. That is correct. And this is the definition of marginal cost. When you produce 1 more unit, the cost increases by the marginal cost. And when you produce 10, then the total cost is 30. So that, in other words, the fixed cost $10 is split over 10 units. So the average cost becomes the marginal cost plus per unit fixed cost. So $3. And when your budget is $40, $10 is deducted for the fixed cost, and then for the remaining $30, you can produce up to 15 units. So all these statements are correct. So then, why did I show you? Well, it is no statistics at all. But what I wanted to show you here is, okay, so like in microeconomics, you assumed marginal cost is, say, a number, and fixed cost is given by another number, and then you learned how to think about these things in these situations. But what we are going to do here is, okay, like we just learned in microeconomics, if you know these two numbers, you can do anything. Pretty much anything is easily calculated. Of course, you need to do some calculus, but that is relatively easy. More difficult is, how do you know these numbers? How do you know these numbers? So that is the problem. See, think about this. You become the CEO of a firm. You open a restaurant. You open a factory. So then you'd like to maximize your profit by setting the correct price, and to do that, you need to understand your cost function first. Okay, then how do you know that? You don't know. You need to estimate them. That is the first thing, right? What you observe is the production, how much you produce, and how much you cost, how much it costs. That's the only observed variables. By the way, the marginal costs and fixed costs are just imaginary parameters. We just assume that there exists such a thing, so you need to estimate them, right? And additionally, what you need to worry about is random errors, right? Sometimes you may make accounting errors, like misspell a number, or you may make some wrong, like a defective products, so that you have to just discard them. They are errors that happen by chance. So, considering all these problems, the first step you have to do is to estimate these numbers, these parameters. And then, given the parameters, like maximizing the profit is kind of standard, just theory, right? You know how to do that. So that is why you are studying this course, and the regression is how you estimate those parameters, right? Often the regression is usually the workhorse in in most economics models. So so this is exactly what I said. If you don't know those parameters, you cannot answer anything. Well, in the end, you want to answer these questions. Then the key is not the theoretical part. The difficulty is not in calculus, but in data analysis. These days, that is the trend. And it's obvious trend. So imagine a data like this. Suppose that you have a factory. Say, what do you make? Tons of smartphones. So in each month, you produce, say, 2 tons of, semiconductor, say, okay, 2 tons of semiconductors, and it costs like $15,000. You observe on your book how much you produced and how much you spent, and you observe for a year, say 12 months. Okay, so from here, this is all you observe, and then how do you find the marginal cost and the fixed cost? That is what we are going to do. So we are going to change. So we observe 2 variables, so you can use a scatter plot to understand their relationship. So output is here, cost is there. Then, as you could expect, when you produce more, of course, cost will increase, right? So output here, say it is December. This is December, this is January, like that. A month is a dot on the scatter plot. So you have 12 observations. And what we want is, we would like to make a trend line here. Yeah, so then to do like mathematically, so the same thing, I'm doing the same thing in different different dimensions. So we graphically illustrated the data. Now we are going to write an equation. This is the regression equation. So I am going to use y for the cost, total cost, right? X is the output. And then beta 0 is the fixed cost. So the total cost is fixed cost plus marginal cost times how much you produce, right? So exactly, beta 0 is the fixed cost, and beta 1 is the marginal cost. So when you produce 1 more unit, then the total cost increases by beta 1, right? And regardless of your production amount, you need to spend beta 0. That is the fixed cost. On top of them, I allow an error term, right? As I said, there can be some kind of errors in terms of like in the process of production or in the process of bookkeeping, accounting, or a lot of errors may occur. So I allow that here, right? So then, exactly this is the equation you learned in microeconomics. Your total cost is fixed cost plus marginal cost times output, and the only difference is error term that I allow, right? And now, in terms of data analysis, statistics perspective, y and x are observed random variables. They are observed and they are random. I say they are random because each month they may be different, right? You choose a random month, then they may be different, okay, from month to month. So I say they are observed and random, but beta 0 and beta 1 are unknown. First, that's because we are estimating that. So we do not know what beta 0 and beta 1 are. They are parameters, and they are constant. Say they don't change. If they change from month to month, then our analysis breaks down. So we should assume that the fixed cost is the same and the marginal cost is the same for throughout a year, right? So we have a constant target. So we are going to estimate those two cost parameters. Finally, error term is not observed and random, right? These are statistical properties of those objects, right? Okay, so what you are going to learn is estimation of beta 0 and beta 1 using data on x and y. So we observe x and y, and we estimate beta 0 and beta 1. Here, epsilon is taken into account. Okay. Examples, more examples. So I just show you the cost function example, but similar examples can be found in many places, in many fields of economics. The one example is demand or supply function. So demand and supply functions are basically the relationship between quantity and price, market quantity and market price. So like demand function, if the market price increases, demand will decrease, right? That is the demand function. Especially in this relationship, we are interested in beta 1. In many cases, beta 1 is very important. So when you increase your price, how much quantity will decrease, right? If beta 1 is big, that means the demand is elastic to the price, sensitive to the price. So you have to keep your price low. But if beta 1 is close to 0, that means even if you increase your price, the demand does not decrease. So just you can increase the price to maximize your profit, something like that. So of course, beta 1 is expected to be a negative number. So anyhow, this is basically another regression model using different, and you only observe the equilibrium quantity and equilibrium price. From there, you would like to estimate the elasticity of demand. Of course, by the way, of course, in real estimation is more complicated than what I explained here, but just basically have the same framework. In macroeconomics, you can think of Keynesian consumption function. So, in Keynesian macroeconomics, consumption is a function of income, right? So, beta 0 is autonomous consumption. This is a must-use consumption, right? So, for your survival, for your maintain your life, for your basic life, you need to spend minimum beta 0, even if you do not have income, right? That is beta 0. But additionally, when you have more income, you are going to increase your consumption with beta 1 rate. So beta 1 is called marginal propensity to consume. You know that, right? You must have heard about this somewhere in macroeconomics. So of course, beta 1 is expected to be a positive number. but less than 1. So even if you earn like $100, you do not spend them all. You save some of them and consume the remainder, right? So the propensity is less than 1. And then estimation of beta 1 is really important because also you must have learned it from macroeconomics. Beta 1 determines the multiplier effect of government spending. So when the government increases the spending by $1, then that circulates around the economy by the rate of beta 1, right? When you spend $1, then the person who receives that dollar will spend beta 1 to another person, and then it circulates. So beta 1 is how much it depreciates as it circulates across the economy. So in macroeconomics, beta 1 is very important. And the point here is, again, it's another kind of regression model. Of course, actual estimation, correct estimation beta 1 has more issues, more topics to consider. But to give you an idea, it's another kind of regression model. So now we are fully into statistics now. So statistical terminology for linear regression model. Y is called dependent variable because Y is generated dependent on X. So we will interpret this way. So when X is given, then Y is generated. Y is determined after X, following X, right? Xn are the parameters and error term. Similar here, say cost, total cost depends on how much you produce, right? And quantity demanded depends on the price offered, right? And consumption depends on the income, right? Here, so in general, Y is a dependent variable. And as opposite, X is independent variable. Or sometimes I don't like, so dependent, independent is confusing, so I usually say X as explanatory variable. So X explains Y. So X explains how Y is determined. So I also use explanatory variable term for X. And beta 0. Beta 0 is mathematically an intercept or a constant term. So this is intercept. And beta 1 is the slope. Because when X increases by a unit, Y increases by beta 1. That is the definition, mathematical definition of slope. Or you may call this coefficient of X because it's multiplied to X. And of course, epsilon has a lot of name. Error term, disturbance, or noise. But you get it, all right? So error term, disturbance terms are basically the name for epsilon, right? So the regression model has a long history and used in a lot of different fields. So they have different names in different contexts. But I think this is pretty much the standard in economics. So as I said, we are going to predict. So we assume Y is generated from X. But what we are going to do is then we are going to predict Y using X. We would like to study how Y is generated based on X. Or that is equivalent to make a trend line on the scatter plot. So in the previous chapter, in chapter 11, I just showed you scatter plot and draw a trend line. I did not explain how I draw the trend line. We are going to study that. So you may draw a trend line in a different way, right? But there is a specific guideline to find the optimal trend line in this case, by the regression model. So we are going to explain that, and this is the prediction line, right? And put it this way. So here, the point, the cross section, when the trend line crosses the vertical axis is the intercept. So even when output is 0, even if you do not produce anything, still you have to pay this much, like electricity, like water bill, utility bill, or wages. Even if you do not produce anything, still you have to pay the wages or insurances, basic taxes, basic things that you cannot avoid, right? That is beta 1, beta 0, fixed cost. And beta 1 is this slope, right? When x increases by 1 unit, y increases by beta 1. That is beta 1. And then relative to the trend line, the deviation is the error term epsilon. So the first observation has negative epsilon, and second observation has positive epsilon. So somewhere epsilon is pretty close to 0, but here epsilon is pretty far from the trend line. So epsilon is random. Can be small, can be big, can be positive, can be negative. But in general, epsilons are mean 0. So average of epsilon should be 0. That is the basic properties of linear regression model. Okay. So in the next video, I'm going to start with Excel, right? I will show you how to estimate this trend line on Excel. Okay. So thank you for watching, and I will see you in the next video.